So welcome back to episode 4. This is where our cube is at right now. We just finished the first layer. And we have this entire ring around, and these colors align as well. If you're not up to there yet, I recommend going back and redoing the steps in previous videos. Hopefully they explain it well enough. But today we're going to be doing the second layer. It's one of the simpler steps of the cube, to be entirely honest. It's only one algorithm, and well, I guess two actually. It's one algorithm and the other side as well, which is the same thing, just mirrored. But this is what we're going to be working on. We're just going to be getting both of these layers done. And to do that, if you look at the unsolved cube side by side, you'll notice the only real difference are these 4 edge pieces here. So this one, this one, this one, and this one. And these are not that hard to do. As I mentioned, it's only one algorithm that has a left and a right variant to it. We're just going to get started here. What we want to do is we want to pick any edge that does not have yellow on it, because at this stage all the white edges are already placed. We don't have to worry about them. But the ones that have yellow are going to be up on top at the end, and the ones that don't are going to be in here at the end. So we want to find ones that don't. So let's start by picking one, and I'm going to pick this one. And I have a reason for picking this one, but it's not too important right now. It's more for demonstrative purposes. To be clear, this algorithm is a little more complicated than the last one. The last one was a bit of a foray into how algorithms work. It's just a very short 4-move algorithm. This one is a fair few more, but it's still very manageable. They come up on the side here. Let's get started. So we picked this piece. This is the red and the blue piece. That means it needs to go between the red and the blue centers. So see, that's right here, of course. So what we're gonna do is we're gonna align this piece with its own color. So it's red and blue, but the side we care about is this one, because this one's the one that's facing us, which is the blue side. So we're gonna start just rotating this until these two colors align. Nope. Nope. Yep, there you go. And now once they do, we need to figure out which side we want to put it to. And that will decide which algorithm we use. So do we want to put it to the left or to the right? So if we look at the left, you don't need to rotate it, but I'm just going to do that for demonstrating. You'll see that this doesn't align. It's orange on red. That's not correct. But to the right, it's red on red. And this looks like where it's meant to be. This looks correct. So we're going to use the algorithm that puts it to the right, which is the first of the 2 algorithms that you see here. So let's start doing the algorithm. It is U, R, U prime, R prime, U prime, F prime, U, F. And as you can see, by doing the algorithm, we've just put that piece perfectly into there. You can watch where the pieces travel as they do the algorithm. You can rewind it and rewatch it if you like. It's a very cool algorithm, and it's pretty cleverly done, and it works very well to accomplish that task. But from here, we're going to work on the other edges. So I'm going to look for another one that doesn't have yellow on it. So these 2 obviously have yellow on them. These 2 do not. So we can use either of these. They both work to the same effect. I'm going to pick this one, which is the red and green. So we're just going to rotate this until it aligns. There you go. Green on green. Does it go right? Nope, doesn't look correct. Let's go left. Yeah. So we're going to be using the other algorithm, which is number 2, I believe. And that algorithm goes U prime, L prime, U, L, U, F, U prime, F prime. As you can see, once again, this is the other variant of it, but works the exact same way. If you're quite astute, you might notice it's actually just the same moves, just on the other side of the cube. So every R you replace with an L prime, and every U you replace with a U prime, and you just swap everything around. So if you want to memorize one, and you just kind of mirror it in your head when you do it, that also works too. So that's the brunt of the second layer. It can all be accomplished just by using those 2 algorithms, but as in most things in cubing, there are certain extraneous cases that are not going to work the same way, and this is one of those. I've intentionally set this up so that it'll be a little bit more difficult to do, but I've done this just so I can demonstrate what one of the worst cases are and how to go about it. So if you look at the top here, there are no pieces without yellow on them. This is a similar issue to the one we had with corners previously. And it can actually be solved in a very similar way. So if you want to try and tackle it, pause here. You can look at the cube and figure out what you can do. Obviously you don't have the cube, so you can't actually do it yourself, but you can try and kind of figure it out and see if you get the right answer. So the actual solution to this problem is once again quite similar to the corners, just placing a random piece into where the pieces currently are. So if you pay close attention, you'll actually see the edges that we want to place are actually inside. So the orange and blue is here, and the orange and green is here. These are the wrong positions for this too. So we need to pull them out and flip them around. And there are some fancy algorithms you can use to do that, but they're quite complicated. And what we can do, which is a very simple method, is we can pick any random piece on the top. Let's pick this one. Doesn't really matter which one, as long as it isn't one we want to use later. And we can just put this into here. So we're just I want to put this piece into here. So I'm going to use the first algorithm. So U, R, U prime, R prime, U prime, F prime, U, F. And now we have that random piece in there. Great. And what's that done? It's actually kicked our piece that we want out of the position, which is perfect because now it means that we can reinsert it into the correct position. So now we want it here. And to do that, we're just going to do it needs to go to the left. So that's the second algorithm. So U prime, L prime, U, L, U, F, U prime, F prime. And there you go. Now the last piece has also been kicked out. So we're just going to we're going to put it to where it needs to go. It needs to go to the left. So second algorithm, U prime, L prime, U, L, U, F, U prime, F prime. And there you go. That's the entire second layer done. And there's one last case that can be kind of annoying. This is a very similar case to the last one, and the solution is effectively the same, except instead of having two swapped around, the piece is just in the wrong way. It's just flipped on its side here, which is also problematic for obvious reasons. So to fix this, what we're going to do is we're just going to, once again, put a random piece in there and then reinsert it properly. So let's just put this piece into here. So U, R, U prime, R prime, U prime, F prime, U, F. That was the first algorithm. And then we're going to go ahead and find the piece, which has been kicked to the top somewhere. It's here. And we're going to align it with its color, which is red. There you go. Now we're going to go ahead and insert it to the right, because that's where we want it to go. So U, R, U prime, R prime, U prime, F prime, U, F. And there you go. That is the second layer done, and that should cover pretty much every unusual or difficult case to work with.